In this lecture, we shall discuss some more advanced level problems on motion in 1 and 2 dimensions. As you have already seen, the problems are further classified into levels 1, 2 and 3. Depending on their difficulty level, we hope this will be helpful for the students as they follow the solutions of the problems. So our first problem in the lecture is also based on motion in 1 dimension, but it compares motions of two different bodies, a balloon and a coin. Problem number 1, I put it in difficulty level 2, telling that a balloon is descending vertically at a constant speed of 3.30 meters per second. At time t is equal to 0, the coin is projected straight up from the balloon at speed 20 meters per second relative to the ground. Part A, what is the distance between the balloon and the coin when the latter reaches the highest point of its path? And in part B, at what time will the descending coin overtake the balloon? As you can see here, the motion of the balloon and the coin projected from it remain confined in a vertical straight line, which I am showing it here. And let me choose my positive y direction, that is vertically downwards. I show it separately. And the initial position of the balloon from which the coin is projected, I take that to be the origin of the coordinate system here. So this is the point whose y coordinate is equal to 0. Let me show the balloon also in my figure. As they have said, this is going down with a constant velocity. So don't make a mistake. Balloon is not a freely falling body. It's moving down with a constant velocity, while the coin, as soon as it gets detached from the balloon, it becomes a freely falling body possessing acceleration due to gravity in the vertically downward direction. So these two motions are somewhat different. I shall be using this letter B for balloon, and suppose the velocity of the balloon is denoted by the symbol VB, that's downward. So here also I write for the balloon given by the symbol B, velocity is constant, which is 3.30 meters per second. Since I have taken downward to be my positive direction, that's why I put a positive value here to denote its downward direction. Acceleration of the balloon, as we said, it is 0. And at this position, that is y0 is equal to 0, at time t is equal to 0, a coin is being tossed from the balloon in the upward direction, so that the coin's velocity with respect to this ground, that's important here. I have drawn this coordinate system of one axis attached to the ground. And with respect to the ground, velocity of the coin, symbol for coin is c and velocity vector is vc. They are telling here that for the coin, for which symbol is c, velocity at the time of projection, that is 20 meters per second upward, right? And we have chosen upward direction to be my negative direction, and therefore I shall take a minus sign before it. Remain careful about these different quantities and their symbols in agreement with my assumed positive direction. And as I already said, acceleration possessed by the coin during its motion, that is AC, and this AC is equal to the free fall acceleration g, that is downward, hence positive 9.8 meters per second square. Now with this information, let's see what they are telling. In the first part, we are supposed to find out the distance between the balloon and the coin when the latter, that is the coin, reaches the highest point of its path, part A of the problem. So suppose the coin is going to this highest position somewhere on this vertical line, and the time at which the coin reaches highest point, that time is taken to be t1. I take this point to be P, and suppose the y coordinate of the coin at this instant, we are calling it yc for coin, comma, at time t1. This is the position coordinate of the coin at its highest position. It goes there, stops momentarily, and then again starts falling under the free fall acceleration. During the same interval of t1, suppose the balloon has descended to this position. So this time is also t is equal to t1, and the corresponding y coordinate of the balloon, that is y, v for balloon, and the time is the same t1. We have to find out, let me take this point to be the point q, and we have to find out the length of pq, that is the distance between the coin and the balloon when the coin is at its highest point. So this is the distance I am looking for. So how do we proceed? As a first step, we shall consider the coin's upward motion, that is from O to P. Let us first find out the value of T1. We apply this well-known kinematic formula, V is equal to U plus AT. For the upward motion of the coin, final velocity is 0 at this point, isn't it? Therefore, V is coming out to be 0. Initial velocity of the coin at the origin O, that is already written to be minus 20 meters per second. We are careful about assigning plus or minus values depending on the sign convention adopted. Plus, acceleration of the coin, that is g, downward, positive 9.8 meters per second square, and the time taken for the upward flight of the coin, that is taken to be t1 already. From here, if you solve, the value of t1 is coming out to be, as you can check, this is 2.04 seconds in 3 significant figures. Once we have the value of t1, let us find out the position coordinate of the coin at the highest point P. And for that, I am going to use one more important formula of kinematics. V square is equal to U square plus twice A into delta y displacement. Let me write it to be the final y coordinate at the end of upward motion minus initial position coordinate, that is y0. In this case, that is the origin. Putting values once again at highest point of the path, the coin comes to rest momentarily, therefore V is coming out to be 0. U, here written already, minus 20.0 meter per second whole squared, plus twice acceleration 9.8 meter per second square, and there the position coordinates, finally position coordinate is named y for coin at time t1 minus y0. This must be equal to 0 because this is the point of launch, isn't it? The point O here, and that is 0. And from this you solve and show that the value of yc t1, this is coming out to be minus 20.4 meter in 3 significant figures. Why the value negative? This position coordinate of this coin at the highest point is in the upward direction from the origin taken to be O, and that, according to my sign convention, is the negative direction. Therefore, I get a negative value of minus 20.4 meter for the position coordinate of the coin at the highest point of its path.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.